Okay, we're going to take notes today over finding the perimeter and area on a coordinate grid. Okay, remember to find the perimeter, you're just going to add up all of your sides, which this bottom, the length of CB is pretty easy. You can just count 1, 2, 3, 4, 5, 6, 7, 8. So that's pretty easy. These other two sides are going to be a little more difficult, so we're going to have to use our distance formula. Remember to find the distance, you take the change in x and you square it, plus the change in y and you square it. And then you take the square root of that and it'll give you the distance. So the length of AB equals, this ordered pair here for A is at 0, 5. The ordered pair for B is at 4, negative 5. So when I look at my x's, I go from 0 to 4. That's a change in 4. When I look at my y's, I go from 5 to negative 5. That's a distance of 10. So change in x squared plus change in y squared, we get 16 plus 100. Which is the square root of 116. Now, if you were asked to give an exact answer, you could leave it, as a square root. You just want to simplify it. So this is understood to be the square root of 4 times the square root of 29, which ends up being 2 square root of 29. And that would be an exact answer for this. Okay, let's move on and find AC. Okay, again, my change in x, I go from the c value, which is at negative 4, negative 5. So I go from an x value of negative 4 to this x value of 0 right here. So that's a change in x of 4. My change in y goes from negative 5 to 5, so a change in 10. So again, square root of 116, which simplifies to be 2 square root of 29. So when you find the perimeter, you're going to add all three of those sides together. So we started with 8, and then we've got 2 square root of 29. Plus the other side that was 2 square root of 29. And when you combine all of those together, these are like terms. They have the same number under the radical, so you can add these numbers in front of the radical together. So that'll be 8 plus 4 square root of 29. And that's your perimeter. If you were to get a decimal for that, it would be 29.541. All right, I'm going to write that over here. That's units, or you could have said 29.541. All right, I'm going to erase that just to give myself some more room. Okay, to find the area, we know the formula for the area of a triangle is 1/2 base times height, and we know the base. It is 8. Now your height has to be perpendicular to that base. It has to form a right angle. So this segment right here is actually perpendicular to this base right here. They form a right angle. So they can be the base and the height together. So the height, if I count that, that's 10. So when I calculate that, half of 8 is 4, and then 4 times 10 is 40. So I know my area is 40 units squared. Now that's an easy way to do this triangle because the triangle was drawn nice up and down like this. You're going to have other shapes that aren't drawn so nicely. So we're going to have to do a little bit more work. I'm going to erase some of this. Okay, I erased all of it. Dang it. Sorry about that. Okay. All right, so, sorry, I keep doing that. All right, so what I want you to think about is a rectangle that you draw around this triangle. Now you can find the area of the rectangle, and then you've got these two triangles, this triangle 1 and this triangle 2. Those two triangles are a lot easier to calculate the area of because they are definitely perpendicular. Now, this one we didn't have to do that, so I'm just showing you another way to do it on this one. It'll make more sense here in a second. But what you'll do is subtract the area of these triangles from the area of the rectangle. Well, my rectangle formula is base times height. The base of this we figured out was 8. The height was 10. So that's 80. Then remember the area of a triangle, 1/2 base times height. The base of this triangle on the left is 1, 2, 3, 4. The height of this triangle is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Which happens to be, sorry, I can just calculate it. It's half of 4, which is 2, times 10, which is 20. And then when you do the other triangle, it's also going to be 1/2 base times height. It also has a base of 4 and a height of 10, so it'll be 20. So when you do 80 minus 20 minus 20, you get 40, just like we calculated before. All right, let's do one that's a little harder. Okay, so first I'm going to calculate the perimeter. So I'm going to find the length of WH first by doing my change in, I'm going to rewrite the formula here just so you remember it. Change in x squared plus change in y squared, and taking the square root of that. So W is at the ordered pair 0, 7. H is at the ordered pair 4, 1. So my x's change by 4 when you go from 0 to 4. My y's change by 6 when I go from 7 to 1. So that's the square root of 16 plus 36, which is the square root of 52. And that's an exact answer that can simplify. We can take square root of 4 times the square root of 13 would give us 52, which would simplify this to be 2 square root of 13. All right, now let's find the length of HS. S is at the ordered pair -3, 5. So if I'm going to go from H to S, my x's are changing from 4 to -3. That's a distance of 7 units. My y's go from 1 to 5, which is a distance of 4 units. So that would be the square root of 49 plus 16, which simplifies to be 65. That is not gonna, that breaks up into 5 times 13, which doesn't have a pair of numbers that can simplify that any further. So we're gonna leave that one just like that. And now let's find the length from S to W. So from -3 to 0, that's a distance of 3 for the x's. From 5 to 7, that's a distance of 2 for the y's. So 9 plus 4 is 13. Okay, so when I find the perimeter, it's going to be those 3 sides added together. So the first one was 2 square root of 13. The next one was the square root of 65. And the last one was the square root of 13. So we've got 2 like terms here. They both have the same number under the radical. This is understood to have a 1 in front, so you can add those numbers in front to be 3 square root of 13 plus the square root of 65. So this would be an exact answer. Units. The decimal answer for this would be 18.879. All right, let's figure out the area. So I'm going to erase a little bit. Okay, so we're going to draw a rectangle around this. This one isn't straight up and down, so we can't easily get a base and height that are perpendicular to each other. We could, but it'd be a lot more work. So the easiest way to do this would be to find the area of the rectangle that's drawn around the triangle, and then subtract out each of these triangles that I'm shading right here. So I'm going to erase those. So we're going to do the area of the rectangle minus the area of triangle 1, minus the area of triangle 2, minus the area of triangle 3. This is going to be 1, 2, and this one will be 3. All right, so this rectangle has a base of 1, 2, 3, 4, 5, 6, 7. So when we do our base times height, we'll do 7, and then my height is 1, 2, 3, 4, 5, 6. Okay, when I do the triangle, I'm going to do 1/2 base times height. So triangle 1 has a base of 1, 2, 3, 4, and then a height of that same 6. Minus triangle 2, which had a base of 7 and a height of 1, 2, 3, 4. And then my third triangle will do 1/2. Its base is 3 and its height is 2. So calculating all of that, I'm going to do 42 minus half of 4 is 2 times 6 is 12. Then the next one, I'm going to do half of 4, which is 2 times 7 is 14. And then minus on the last one, that becomes 3. So when I calculate that, I end up getting 13 for my area. So 13 units squared. All right, so let's do another example. Okay, again, we're going to find the distance in order to find the perimeter of each side. So the length of OC equals, this 0, right, or O, sorry, is at the ordered pair 0, 7. C is at the ordered pair 3, 5. So the change in x, I go from 0 to 3. That's a distance of 3 for the x's. My y's change by going from 7 to 5, which is a distance of 2. So that's going to be 9 plus 4 under the radical, which is the square root of 13. All right, let's find the length of CK. So K is at the ordered pair 1, 2, 3, -3, -1. So my x's change from 3 to -3, which is 6. My y's change from 5 to -1, which is also 6. So we have the square root of 36 plus 36, which is the square root of 72. 72 is the same thing as 36 times 2, so you can think of that as the square root of 36 times the square root of 2, which is going to simplify to be 6 square root of 2. All right, now let's do K to S. So S is at the ordered pair -6, 0. So when you go from -6 to -3, that's a distance of 3 for the x's. My y's go from -1 to 0, so that's a distance of 1. So that's going to be 9 plus 1, which is the square root of 10. All right, now we'll go from S to R. R is at the ordered pair 1, 2, 3. So -3, 5, sorry. Okay, so if I'm going to go from -6 to -3, again, that's a distance of 3 for the x's. I'm going to go from 0 to 5, so that's a distance of 5 for the y's. So that's 9 plus 25, which is the square root of 34. All right, and then we'll go from R to O. So R goes from -3 to 0 for the x's, so a distance of 3. It goes from 5 to 7 for the y's, so a distance of 2. So that's going to be 9 plus 4, which is the square root of 13. All right, so we've got 1, 2, 3, 4, 5 sides, and we've got these 5 sides found. So we just need to add those 5 together to get the perimeter. So our perimeter will be the square root of 13 plus 6 square root of 2 plus square root of 10 plus square root of 34 plus the square root of 13 again. These are like terms, so you can combine those to be 2 square root of 13, and the rest just have to be rewritten out because they don't have the same numbers under the radical and can't be simplified any further. So this represents an exact answer for the perimeter. And if you were to get the decimal for that, it would be 24.690 units. All right, let's find the area. I'm going to erase this. Okay, to find the area, I'm going to draw a rectangle around this shape. And I'm going to do the area of the rectangle minus the area of triangle 1, minus the area of triangle 2, minus the area of this triangle 3, and minus the area of this triangle 4. Okay, the rectangle is 1, 2, 3, 4, 5, 6, 7, 8 units by 1, 2, 3, 4, 5, 6, 7, 8, 9 units. So it's 8 times 9. Oops. Triangle 1, you're going to do 1/2 its base times its height. It has a base of 1, 1, 2, 3, and a height of 2. The second triangle has a base, a base of 6 and a height of 6. Triangle 3 has a base of 3 and a height of 1. And then triangle 4 has a base of 7, or yeah, we can say 7. And then its height is going to be 6. All right, so we get 72 minus, all right, minus this becomes 3, minus this becomes 18. The next triangle's area is 3/2, or we can say 1.5, and the next triangle's area will be 21. And when you subtract all of those, you should get 28.5. So the area of this figure would be 28.5 units squared. All right, now y'all can practice on your own. Thanks.